Something from another star had arrived. The name on every astronomer's monitor was 3I, Atlas, an object no one had seen before blazing into the solar system like a cosmic arrow. Its speed defied belief. Its chemistry defied logic. It wasn't just another interstellar visitor. It was different, colder, sharper, richer in carbon dioxide than any comet ever recorded. 8 times more CO than water. Whatever this thing was, it wasn't built by the rules of our neighborhood dot by mid-July 2025. 3I, Atlas was racing toward Mars, 30 million kilometers out and closing fast. On Earth, telescopes tried to track it, but the sun's glare blinded nearly every instrument. In space, NASA's rovers on Mars began reporting something else entirely strange: organic readings from Jezero. Craters, ancient river beds, patterns and textures in the Martian dust that seemed almost alive. The coincidence was impossible to ignore. A comet loaded with exotic ices heading straight from Mars, and at the same time, signs of possible life emerging from the same region. Was this pure chance or something engineered, something that was meant to happen? Astronomers tried to stay objective, but beneath the data and orbit models, a quiet unease grew. 3-1, Atlas's trajectory was hyperbolic, its eccentricity greater than 1, meaning it would never loop back, never return. It was on a one-way passage through our system at nearly 68 kilometers per second, faster than any natural object born under our sun. In December 2025, it would pass Earth at a safe distance of 269 million kilometers. But even that seemed too close for comfort. The glow round its icy heart, the coma, was unnaturally bright, laced with chemicals that shouldn't coexist. A normal comet carries mostly water vapor. Astronomers call it the dirty snowball model. But 3I, Atlas was rewriting that rule. Its spectrum screamed carbon dioxide. Something about it spoke of places colder and darker than anything in our system. Perhaps the frozen edge of another sun, or even the silent reaches between stars. Whatever its birthplace, it carried the fingerprints of alien chemistry, a frozen message from beyond. Meanwhile, Mars kept its secrets. Billions of years ago, rivers carved through the planet's red dust, spilling into the vast delta of Jezero crater. Fine grains of silt and clay buried traces of that vanished world, preserving them like time capsules. Today, those layers were being unsealed by human machines, and what they revealed sent whispers through the scientific community. Under the high-resolution lenses of orbiters, researchers noticed strange mottled shapes, rounded blotches dotting the delta's surface. They called them leopard spots. Some said they were simple mineral patterns. Others dared to suggest something more possible: biosignatures, fossilized traces of once living colonies. Dr. Hiroshi Tanaka, a planetary chemist who'd spent half his career studying Martian sediments, warned against jumping to conclusions. Rivers, he said in a briefing, are nature's vaults. They preserve organics from the world around them. But preservation is not proof of life. Still, even he admitted that Jezero's delta was the most promising place in the solar system. The fine organics, Martian or otherwise, that was the danger. If new organics suddenly appeared in the data, no one could say for certain whether they came from Mars's ancient past or from something newly delivered across millions of kilometers of space. Then came the data from July 18, 2025. From the peaks of the Canary Islands, the Gran Telescopio Canary is locked onto 3I, Atlas, and measured a carbon dioxide to water ratio of nearly 8-1. No known comet in our solar system had ever shown such numbers. Some skeptics blame calibration errors. Earth's own CO-filled atmosphere can confuse even the best instruments. But when follow-up readings from KEK in Japan and the Nordic Optical Telescope confirmed the anomaly, doubt turned to wonder. Even the lowest estimates, around 5-1, were unheard of. It was as if 3I, Atlas, had been forged in a place where water itself was rare. Then came the green glow. Spectrometers picked up a spectral tint linked to carbon and cyanide molecules that shine only under extreme conditions. The coma of 3I, Atlas, burned with an eerie emerald light, brighter and more energetic than models predicted. Some theorists claimed it meant the comet formed beyond the traditional water ice line, where only CO and exotic compounds could freeze. Others proposed something stranger, that radiation from deep space had cooked its surface over millennia, creating new chemicals never seen before. Every new image deepened the mystery. Every new number raised the stakes. And as August approached, astronomers realized their time was running out. The comet's path would bring it closest to Mars on October 3, 2025. just 0.19 astronomical units away, about 28 million kilometers. But the geometry of the encounter was brutally unfair. During those critical weeks, Mars and the comet would both pass behind the Sun from Earth's point of view. The result, a total observational blackout. From late September through late October, the Sun's radiation would drown out all signals. Earth's telescopes would have to shut their domes. Even radio links to Mars orbiters would fade into static. The most important cosmic flyby in decades, an interstellar object brushing past the one planet where we search for life, would unfold in near total darkness. The odds of such a coincidence were almost impossible. Roughly 1 in 100 per century, according to orbital simulations. It felt like the universe was playing a cruel joke. A messenger from another star passing the one world that might have once known life right. When no one could watch, still, not everything would be blind. A few robotic sentinels orbiting Mars, the ESA's Mars Express and the ExoMars Trace Gas Orbiter, would continue their programmed routines through the blackout. They would be the only eyes left open, the last chance to capture any clue before the data stream would silent. Dr. Frank Wilson, project scientist for Mars Express, called it a once-in-a-lifetime gamble. The high-resolution stereo camera aboard his orbiter, capable of mapping the planet in 3 dimensions, was now aimed at the skies. If 3i, Atlas interacts with Mars, he said quietly during a late-night press call, even a single frame could change how we see the universe. The countdown had begun, and somewhere, beyond the blinding halo of the Sun, 3i, Atlas kept coming. As the blackout deepened and Earth lost sight of Mars, a few robotic eyes stayed awake in the void. Two machines, the SAS Mars Express and the ExoMars Trace Gas Orbiter, orbited the red planet in silence, following their pre-programmed instructions. They were the last witnesses to an event that would unfold beyond human control, beyond even real-time observation. Their sensors were sensitive enough to detect the faintest whispers of chemistry light, scattered through gases, molecules splitting and recombining in the thin Martian sky. The high-resolution stereo camera aboard Mars Express could capture wavelengths from 380 to 1,000 nanometers, mapping light invisible to the human eye. But at a distance of 28 million kilometers, even this marvel of engineering would see 3i, Atlas, as little more than a dot, 128,000 kilometers, compressed into a single pixel. The nucleus and the glowing coma would merge into one blurred point of light. Unless something extraordinary happened, unless the comet erupted, the chances were slim. But if 3i, Atlas released a sudden jet of gas, a cosmic exhale bright enough to break the noise, Mars Express might just glimpse its true shape. For the first time, on the Trace Gas Orbiter, the Nomad spectrometer prepared for a different kind of hunt, tuned for ultraviolet and infrared light. It could sniff out gases like carbon dioxide and water vapor, the very compounds that made 3i, Atlas so strange. If the comet's plume washed through space with enough force, it could leave a detectable fingerprint in Mars' upper atmosphere, a faint but telling chemical shadow. Nomad had once tracked methane at parts per billion levels. Now it was listening for a whisper from across millions of kilometers. Every byte of data mattered. But during solar conjunction, communication with Earth was nearly impossible. The orbiters operated blind, running on scripts uploaded weeks in advance. No real-time commands, no adjustments, no second chances. Data would pile up in onboard storage, unseen, unread, until the Sun moved and the radio signals returned. If the memory failed too soon, precious observations could be lost, forever deleted before anyone even knew they existed. The comet's predicted brightness hovered near magnitude 17, barely above the threshold of detectability. HRSE and Nomad might record a faint spike, or nothing at all. Dr. Frank Wilson and his team argued deep into the night about how to use the limited observation slots. Each frame, each scan, had to count. They knew the odds were against them. The likely outcome? A series of upper limits measurements proving only what wasn't there. But even that would be data, boundaries drawn around the unknown. And yet, everyone secretly hoped for something stranger. A flash of light, a spike in an exotic isotope, a molecule that didn't belong. They wanted the universe to surprise them. Speculation on Earth spread faster than the comet itself. Scientists, journalists, and dreamers divided into camps. The first group, realists, believed 3i, Atlas, was a rare but natural wanderer. Interstellar flux models showed that an object like this might pass within 0 point to astronomical units of Mars once every few centuries. A cosmic coincidence, nothing more. The statistics fit. Randomness could mimic design. The universe, after all, had infinite patience for unlikely events. The second camp dared to imagine something else entirely. What if this wasn't an accident? What if the comet had been steered? Its 8-to-1 ratio of carbon dioxide to water was unnatural by any known standard. Its emerald glow hinted at energetic molecule cyanids, and the carbon's compounds tied to active chemistry, and its path brushed directly past Mars. Just as new claims of biosignatures were making global headlines, could it be an ancient delivery system, a deliberate courier seated across the stars? If that were true, there should be science's tiny deviations from physics, like a subtle non-gravitational push, a jet that fired against sunlight, or isotopic ratios to deliberate to be random. But so far, there were none. The trajectory was clean, the radio spectrum silent, no signature of guidance, no trace of intent. Still, Mars orbiters were on alert. They watched for any anomaly, rare isotopes, chemical spikes, a sudden burst of infrared light. Because if even one such clue appeared, everything we knew about cosmic origin would change overnight. The third possibility carried both wonder and dread. Panspermia, the idea that life, or the raw material of life, drifts between worlds. Maybe 3I, Atlas wasn't artificial at all, but a relic of biology's long cosmic journey. If its dust carried complex organic molecules, amino acids, carbon chains, prebiotic precursors, and if those isotopes matched meteorites found on Mars or Earth, the case for interstellar transfer would grow, but proving that was almost impossible. A spike in organics wasn't enough. Scientists needed isotopic fingerprints, ratios of carbon, nitrogen, and oxygen that couldn't have formed in the same stellar nursery as our own. Only that could rule out coincidence. 3 theories, 3 interpretations of the same data, nature, design, or something in between. Meanwhile, the world outside the labs was spinning its own stories. Social feeds filled with memes of cosmic delivery systems and Martian mail. Conspiracy threads claimed 3I, Atlas was a coded message, a celestial time capsule sent long before humanity could receive it. Astronomers tried to steady the narrative. Extraordinary stories, they reminded the public, require extraordinary evidence, and yet, the questions wouldn't fade. Why such an extreme carbon dioxide ratio? Why now, when Mars showed its strongest hints of organics in years? And why a path so precisely aligned with Yazero's coordinates, even if by chance? When communication finally resumed weeks later, the orbiters began their slow data dump back to Earth. Gigabytes of compressed light and noise streamed across the void. Analysts combed through every pixel, every spectral line. For days, nothing unusual appeared. Just background hum, expected radiation, static dot, then came one odd blip. A faint, narrow spike near the 4.3 micron wavelength, exactly where carbon dioxide fluoresces under ultraviolet. At bombardment, but its isotopic ratio was off. Too heavy, too old. Not Martian, not solar dot. It wasn't proof, but it was enough to start a whisper. What 3I, Atlas had brought wasn't an answer, but a question one so vast it blurred the line between science and story. Its close pass by Mars was a cosmic experiment nature rarely performs. A chance alignment of chemistry, gravity, and timing that forced humanity to confront the edges of its own understanding. Whether the object was a wanderer, a messenger, or a relic of ancient life, it had done something extraordinary. It made the world look up again. It reminded us that the frontier of discovery isn't in the data alone, but in the courage to ask what the data might mean. In the end, 3I, Atlas kept its secrets. It moved on, shrinking into darkness beyond Mars' orbit, its green light fading into the endless black. But somewhere in that fading glow was a truth we hadn't yet learned to read, one written not in words, but in chemistry, trajectory, and time dot, and if life really does travel among the stars, then 3I, Atlas was not the end of the story. It was only the beginning.